Section 6, we learn about completing the square. It's a very important, very nice thing to know how to do. We're going to do a little bit of lead up before we get into completing the square, though. So that's what's going to happen here. The little paragraph says our goal when solving equations, always, doesn't matter if you're in Algebra 1 or Geometry, Algebra 2 or Calculus, your goal if you're trying to solve an equation is to get x by itself. In the last section, we were getting x by itself by using the zero product property to split things up and then solving for x, and we would wind up with two answers. Okay, that's always the goal. When you're working with quadratics, so the stuff that we've been working on, we have a new method here. One method is factoring. That's what we learned. We could also graph. We learned that already. Another method that we already learned is using the zero product property. That's what we were doing last time. Sometimes, though, we can't factor. Sometimes we can't use the zero product property. But what we can do is trick the equations that we're looking at into letting us use the zero product property. So we're going to start off by just kind of revisiting kind of an important little rule that we learned in Algebra 1 here. Another property right here. This is what we're doing right now. It's called the square root property. So rather than factor, rather than graph, rather than try to use the zero product property, we can use something called the square root property. To use the square root property, you need to only see an x squared term. There cannot be an x term. If that's the case, then get the x squared term by itself on one side, and then you can take the square root of both sides. This only works, though, right here, if you only have the x squared term. So take a look at these three examples. In that first one, we have 4x squared plus 10 equals 46. There is no x term. So we can use the square root property. So to get x squared by itself, what do I need to do first? No, we do not divide first. We subtract 10 first. Get the x squared term by itself. So we subtract 10 from both sides, and now we have 4x squared equals 36. Now divide both sides by 4, and we get x squared equals 9. Well, if x squared equals 9, then we square root both sides to get x by itself. Square rooting undoes squaring. And that gives me x equals not just 3, plus or minus 3. Remember, if we're squaring x to get 9, then 3 works, but negative 3 squared is also 9. So that's why we have to say plus or minus 3 here. If we're dealing with a story problem where the negative doesn't make sense, then we can get rid of it. But this is not a story problem. It's not a distance. We have to leave the plus or minus. You have to have it there, otherwise it's wrong. And that's using the square root property. You manipulate this down to get x squared by itself, and then you take the square root of both sides and get your answer, plus or minus. So for the middle one, what should we do? Add 10 to both sides. And if I do that, I get 7x squared equals, if I added 10 to both sides, I get 35. Now what? Divide both sides by 7, and now I have x squared equals what? 5. Now what? Square root both sides, and I get x on the left equals plus or minus the square root of 5. You can't simplify that. We're going to leave our answer just like that. Do not go to decimal. Leave it as the square root. Why don't you go to decimal? Because then you're giving me an approximate answer and not the exact answer. It's going to stay as a root. We're going to simplify roots a lot. So if you don't remember how to do that, we'll review it. Next one, what do? Subtract 9 from both sides, and now I have 2x squared equals 4. Now what? Divide both sides by 2, and I get x squared equals 2. Now what? Square root both sides. Now what? The square root of 2. The square root of 2 does not simplify, so you leave it the square root of 2. That's your answer. All right, so we have an architecture problem and a little applied problem of what we're doing. It says, while designing a house, an architect used windows like the ones shown here. What are the dimensions of the window if it has 2,766 square inches of glass? We're talking about the window here, not this part. Okay? That's not an X. I'm just like crossing it off. We're not talking about that top part. I would do that if I was asking you for the perimeter. I'm not asking for the perimeter. I told you that it has this. What is that? What is square inches? That's an area. You need to see that and realize that we're talking about area. And then you need to remember how to find the area of a rectangle. Base times height, or length times width, or whatever, okay? So we have the height, which is 2x. So the area equals base times height, or length times width, or however you want to write that down. So the area that we have is given to us as 2,766 equals the base times the height. Well, the base is x, and the height is 2x. So that becomes 2766 equals 2x squared. And I want to solve for x. Now what? Divide both sides by 2. And what is 2,766 divided by 2? 1,383. Okay. Now what? Square root both sides to get x by itself. And we get x equals plus or minus, okay. You did the hard part, now for the easy part. Just type in square root and then 1383, enter. 37.18. So if I'm rounding to the nearest tenth, then it would be 37.2 what? Inches. Okay, so on this one, we did take the square root and do the decimal approximation because it's a story problem and the square root of 1,383 makes absolutely no sense to anybody. So we want the approximation. But we included the plus or minus here. This is a length. So can I have negative 37 inches? No. So my actual answer is going to be x equals 37.2 inches, not negative. And what is that 37.2 inches? What is that? It's a dimension. Which dimension is it? Yeah, it's x, but which dimension is that?
The base, the length.
That's x right there. So that's the width. I got to find the dimensions. It says what are the dimensions? I'm not just solving for x here. So I also need the height. What's the height? .4 what? Inches is the height. So there's my answer. Real world problems, story problems, you're going to have decimal approximations possibly. But make sure that you actually answer the problem. It says what are the dimensions? These are the dimensions. Don't just stop at x. All right, we can use this idea of the square root property on problems that look like this. It saves time if you can recognize the perfect square trinomial. If you don't recognize the perfect square trinomial, then what would you probably do to this problem to get started? You'd subtract 25 from both sides and get equals 0, right? Well, there's little subtle hints here that tell me that maybe that's not what I want to do. Take a look at 25. Is that a perfect square? Yeah. Take a look at 4. Is that a perfect square? Yes. Take a look at x squared. Is that a perfect square? Yes. It's possible that this thing right here, sitting here, is a perfect square trinomial. If it is, then you can make it a perfect square trinomial, or make it look like a perfect square trinomial, and then use the square root property on it, and simplify your problem a lot. So let's do that. To check to see if it's a perfect square trinomial, we take the square root of this term, and multiply it by the square root of that term. So the square root of this guy is x, the square root of this guy is 2. We multiply them together and we get 2x. And then we double that result. Does that give me the middle term? Yes. So this is a perfect square trinomial, which means I can write it like 1 squared equals that 25 still sitting there. Now before I fill in what's in there, notice that I have something being squared. In order to get rid of that square, what can I do to it? I could square root it, and that will eliminate that squared part. But if I square root one side, I have to square root the other side. And that's where the square root property becomes really nice to use. So inside we have x, we have 2, and then the sign in between is plus. Does anybody need a refresher on that? No? Okay. It's just the square root of that, and then that sign. So now we have x plus 2 squared equals 25. Square root both sides. When I do that, the square and the square root disappear. They wipe each other out, and I'm left with the x plus 2 equals what? No. Plus or minus 5. So that's like two separate equations. We have x plus 2 equals positive 5, and we have x plus 2 equals negative 5. But we can still solve this equation for x. Subtract 2 from both sides. When I do that, I wind up with x equals negative 2 plus or minus 5. And now I can simplify that, because I can do this math. This gives me x equals negative 2 plus 5, which is 3, and this also gives me x equals negative 2 minus 5, which is negative 7. That's how I get my two answers here. The first time you see what we just did here, maybe it doesn't seem like the easier way to go, but trust me, it is. If you're dealing with a perfect square trinomial. Again, if you don't see that it's a perfect square trinomial, you'll probably move that 25 over and then potentially wind up stuck. So you need to see it. Second one over here, what are we going to do? Check to see if it's a perfect square trinomial, because I'm seeing perfect squares in the problem. That's always a red flag. I see that 49, and I know that that's a perfect square, so I'm thinking maybe it is. So I have x squared over here. Is that a perfect square as well? Yes. So I go, square root of that is x, square root of that is 7, so I have 7x, double it. Do I get the middle term? Yep. So this is a perfect square trinomial. So I can write it like one. X minus 7 inside the parentheses. Good. Now what? Square root both sides. And we get plus or minus 5. Once you take the square root symbol's gone. Now what? Add 7 to both sides, and you have x equals what? 7 plus or minus 5. Okay, now we actually can simplify that down, so we have to. We get two answers. X equals 12. X equals 2. There you go. Yeah, it says 7 plus 5, which is 12, and then 7 minus 5, which is just 2. Okay? Really what you're seeing here is two equations. All right? All right. Next one. What should we do? Check to see if it's a perfect square trinomial. So we have x here, we have 6 here, so we have 6x. Double it. Do we get the middle term? Okay, so it is a perfect square trinomial. So we can write it like 1 equals 9. What's inside the parentheses? X plus 6. Now what? Square root both sides. X plus 6 equals plus or minus 3. Subtract 6 from both sides, so x equals. Good. So we can simplify that. We get x equals negative 6 plus 3 is negative 3, and then x equals negative 9. Negative 6 minus 3 is negative 9. There's my two answers. And the last one? Square root here is x. Square root here is 3. So we have 3x. Double it. Do we get the middle term? 3x doubled is 6x. The sign here is not what we're looking at, just the term itself. Okay? The sign tells me the sign inside when I make this a perfect square trinomial. What do I write? X minus 3. Now what? Square root both sides. And we get? What's the square root of 1? 1 times 1 is 1. So the square root of 1 is 1. X minus 3 equals plus or minus 1. Now what? We added 3 to both sides, and now we have 3 plus or minus 1. So that gives me x equals 4. X equals 2. Now that's how you do that. On the last page, we had a square root that we took that we couldn't simplify, right? We had the square root of 5. So if you were to wind up with like a 5 sitting here, and you took the square root of 5, you just leave it the square root of 5, and then you'd have 3 plus or minus the square root of 5, which can't be simplified, so that's your answer. Okay? It saves you the trouble of having to type it into the calculator and then continue to work with those decimals. Just leave it as the square root if you can't take that square root. So remember, when taking the square root of both sides of an equation, there are always two answers. You will have plus or minus here, and you will wind up with two answers. Okay, so we've been working with perfect square trinomials. They were nice and perfect squares, so we could turn them into perfect square looking things, take the square root of both sides, and life was happy. But when we don't have a perfect square trinomial, we can't do that. So what we're going to do is learn how to turn something into a perfect square trinomial. We're going to trick the equation into becoming a perfect square trinomial so that we can do what we just did. Because life is easier when you can do that. Agreed? I mean, we weren't factoring at all, right? We could have gone back and factored all those problems. It would take forever, probably. So that's what's going on here. We need to learn how to do what's called completing the square. If you're going to complete the square, then you're trying to make a perfect square trinomial. So the question here is, what do each of these c values here need to be in order to turn these problems into perfect square trinomials? So what's the first one got to be? I want a number. What number has to go in for C? 25? Let's try that. If it's 25, so obviously it's got to be a perfect square, right? In order to make that a perfect square trinomial. So we're only looking at 1, 4, 9, 16, 25, and so on. If this was 25, then if I check to see if it's a perfect square trinomial, what do? Square root of 25 is 5. The square root of x squared is x. Multiply those together and you have 5x, and then double it and you get 10. So is 25 the answer here? Yes. C would have to be 25. $25 is fine. On this one? 9. How'd you do that so fast? Okay, so she's right. It is 9. But you're not doing it the fast way. 49 is right. How did you do that? That's the fast way right there. You got it. So if you're given the trinomial, to check to see if it's a perfect square trinomial, you take the square root of this, multiply it times the square root of that, and then double it. Well, you're not given this number, right? So instead, you could go backwards. You have that number, so instead of doubling this to get to that, divide this number by 2, and then square it, and that will give you this number. If I take 10 and divide it by 2, I get 5. 5 squared is 25. If I take 6 and divide it by 2, I get 3. 3 squared is 9. If I take 14 and divide it by 2, I get 7. 7 squared is 49. So now you know how to make a perfect square trinomial if you don't have this number sitting right here. I'll show you how to work with that now that you understand this. Do you understand this?
Yes.
Okay, this is the important thing. Now, in answering the above questions, what we are doing is a process called completing the square. You are completing the square when you take this number divided by 2 and then square it. You've made a perfect square trinomial. You're basically tricking the math, or tricking the equation, into thinking that it's a perfect square when really it wasn't to begin with. Okay? So we're just tricking what we're doing now. It's like magic. So the process of completing the square is sitting right here. Very officially, this is like the official notation. If I have b on that x term, then I need to take b and divide it by 2. When I do that, I have b over 2. And then I'm going to square that result, and that's what's sitting right here. No. Now once you've completed the square, then this trinomial turns into this guy being squared. Because now these are all perfect square trinomials. This one then would turn into x minus 7 squared. This one turns into x plus 3 squared. This one turns into x minus 5 squared. Once I complete the square. And that's what that's saying right there. I take b, divide it by 2, and I square it. It gives me that number right there. Well, the same thing occurs. B divided by 2 winds up sitting right there when I make it a perfect square. We're going to use this idea. This is not the whole thing. We're using this idea to help us solve quadratic equations with the square root property. Here are the official steps for remembering how to complete the square. Yeah, probably want to write these ones down. First, you're going to rewrite the equation as x squared plus bx, meaning leave out the c, or move it to the other side. If there's an a other than 1, at that point, you will factor that a out. The a itself. Even if a is not the GCF of the problem, you're going to have to factor it out. Or you could divide everything by a since you're working with an equation. And you'll see examples of that. Once you're there, find half of b, and then square that result. That was what we were doing when we were completing the square. But then this right here is most important. Add whatever you just added in to complete the square to the other side of the equation as well to keep it in balance. And then you can solve by taking the square root of both sides and then simplifying it down, and then you'll have x by itself. So the directions here say solve by completing the square, and then remember, what you do to one side has to also be done to the other side. So let's take a look at that first one. I want to solve by completing the square. Follow the steps. It says rewrite the equation as x squared plus bx, meaning we need to get the c term out of there. So either we push it off to the side or we move it to the other side. In this case, we're going to move this to the other side. So to do that, I have to do what? Add 11 to both sides. Now I'm going to write x squared plus 10x, and then I'm going to leave a gap where the negative 11 was, and then write equals 11 because I added 11 to both sides. Now what I want to do is turn this into a perfect square trinomial on the left side. So what number would this have to be right here in order to make this a perfect square trinomial? 25, good. So to find that, I take 10, divide it by 2, and I get 5, and then I square it, and I get 25. So if I had a plus 25 sitting here, then that would be a perfect square trinomial. Well, look at what I just did. I just added 25 to the left side. I have to add 25 to the right side to keep it in balance. And that's exactly what I'm saying right here. Add the result from step 3 to your original equation. Keep the equation in balance. What you do to one side, you must do to the other side. We added 25 here, so we must add 25 here. Now the equation is still in balance. So, now I have a perfect square trinomial sitting here. It becomes something squared equals 11 plus 25, which is 36. It's x plus 5 in the parentheses. X plus, from that sign, and then half that number, 5. Well, now I have x plus 5 squared equals 36. What can I do to solve for x? Square root both sides. And when I do, I get x plus 5 equals plus or minus 6. And now we subtract 5 from both sides. X equals negative 5 plus or minus 6. I can simplify that, so I write x equals negative 5 plus 6, which is 1. X equals negative 5 minus 6, which is negative 11. There's your two answers. We didn't have to factor because we turned it into a perfect square trinomial and then used the square root property. For the second one, what should we do? Subtract 24 from both sides to get the 24 on the other side. We have x squared minus 10x, leave a gap, equals negative 24. Now what? Complete the square. Use the right language. We're going to complete the square to make this a perfect square trinomial. To get there, we have to... half of b is 5, and then square it, and we get, so I write plus 25. It's not always going to be 25. Yeah, we just added 25 to the left side, which means we have to add 25 to the right side as well. So now on the left side, we can simplify that. It's a perfect square trinomial now, so we can write it like a perfect square. Equals, this becomes 1, and inside the parentheses here we have x minus 5. It's not plus or minus 1 yet. We haven't taken the square root of both sides. Now what? Square root both sides. And we get equals plus or minus 1. Now, adding 5 to both sides gives me 5 plus or minus 1 on the right side. And so we can simplify that. X equals 6. X equals 4. And finally, well, hang on. I see a 9 here. Is this a perfect square trinomial already? Yes?
No.
No? How do I know?
It's not a, no. Yes, it is.
There's a 9 here. That's a perfect square. But, right, b should be 6. The square root of 9 is 3. Double it, and you should see a 6 here, and we don't. So this is not a perfect square trinomial right now, okay? But if it was a perfect square trinomial already, then you don't have to complete the square and something that already has the square completed. So what would we do here? Subtract 9 from both sides, and now we have x squared plus 10x, leave a gap, equals negative 9. Now what? So we get 25 again. We're adding 25 into both sides. It's not always 25. It just worked out on these three problems. Now what? This is now a perfect square trinomial, so we can write it like a perfect square. X, what? Plus 5 squared equals 16. Now what? Square root both sides, and you get equals plus or minus 4. Now what? So subtract 5, x equals 4, okay, and then we can simplify that, so x equals negative 1, x equals negative 9. Good. Solve by completing the square. This is the other, the way the other side lives. It's not always going to be x squared. A is not always going to be 1. Sometimes it's going to be something else. So what we want to do here is what?
GCF.
Factor out a GCF. In this case, the GCF is 3. Now I could factor out a GCF, or because this is an equation equal to 0, I can actually divide everything by that GCF right now to get rid of it completely. So I'll divide all three of these terms by the GCF of 3. Also divide the right side by 3. So now on the left I have what? X squared minus, good? There you go. And now we can do what we were doing on the last page. So I'm going to boot that 2 to the other side. It becomes x squared minus 4x, leave a space, equals negative 2. Complete the square. 4. Take this b, divide it by 2, and you get 2. Square it, and you get 4. So I'm adding 4 in on this side, which means I have to add 4 on the other side. So now we have a perfect square trinomial here. It will turn into what? Squared equals 2. Now what? Square root both sides. And we get plus or minus the square root of 2. I can't simplify the square root of 2, so it stays the square root of 2. Plus or minus square root of 2. We're not done. We've got to solve for x. X has to be by itself. So we're going to add 2 to both sides. X equals 2 plus or minus the square root of 2. And that's the answer. We can't do anything further than that. You don't have to write it as 2 separate answers. We understand that both answers are sitting there. So that's your answer. For the next one, last one of the day, 2 minutes. 2-minute drill here. I got to have equals 0, right? Okay, so I got to subtract x from both sides, and then I got to subtract 9 from both sides. Once I do, I have 2x squared minus 2x minus 6 equals 0. And my next move is to do what? GCF is 2. So I can divide everything, every little thing here, by 2. And when I do that, I have x squared minus x minus 3 equals 0. I want to solve by completing the square. So that means I got to boot the negative 3 over here, and now I have x squared minus x, leave a space, equals positive 3. It's not 1. This is 1 here. Half of this number is 1/2. 1/2 squared is 1/4. So plus 1/4. Plus 1/4 on this side as well. So now this is a perfect square, equals 3 1/4. 3 1/4 is 13/4. Inside we have x minus 1/2. Now square root both sides. And we have x minus 1/2 equals plus or minus the square root of 13 divided by 2. We add 1/2 to both sides and we get x equals positive 1/2 plus or minus the square root of 13 over 2. Which I could write common denominator, x equals 1 plus or minus the square root of 13 over 2. If you didn't follow this right here, then you need to refresh your memory on how to simplify roots, and we can do that. You just got to let me know. But this is the answer right here.